Good morning, students. Myself, Srinivas, Assistant Professor, Department of Physics, Kakatiya Institute of Technology and Science, Warangal. Welcome to video lecture on Microwave and Optical Fiber Communications. Subject code U18EC702C. Topic: two cavity Klystron amplifier. Classification of microwave tubes. Microwave tubes are classified into two categories. The first one is O type and the second one is M type. In O type, the applied electric field and the magnetic field are parallel to each other. In cross-field tubes or in M type, the applied electric field and magnetic field are perpendicular to each other. In this chapter, we are going to study two cavity Klystron amplifier, a reflex Klystron oscillator, and magnetron, 8 cavity cylindrical magnetron. Introduction. Microwave tubes are constructed to overcome the limitations of conventional tubes at microwave frequency. The basic principle of operation of microwave tubes. Microwave tubes works on the principle of velocity modulation. Velocity modulation. The velocity of electron beam varies in accordance with RF input voltage. Velocity modulated electrons form bunching by losing energy. Klystron. Two cavity Klystron amplifier is basically a velocity modulated tube. Klystron is a specialized linear beam vacuum tube invented in 1937 by American electrical engineers, Russell and Sugard variant. Construction of two cavity Klystron amplifier. This is the schematic diagram of two cavity Klystron amplifier. The Klystron amplifier consists of electron gun. In that, this is the position of cathode where the electrons are generated, and this is the position of anode. Here, the filaments or focusing electrodes are used inside the electron gun to focus the generated electrons into the tube. And along with electron gun, it consists of buncher cavity and catcher cavity. Here it is having two cavities. That is why it is called two cavity Klystron amplifier. The buncher cavity is called input cavity and the catcher cavity is called output cavity. The position of the gap inside the buncher cavity is called gap A, and the gap inside the catcher cavity is called gap B. The space between the buncher cavity and catcher cavity is drift space. Here, the input will be applied at the buncher cavity through coaxial loop, and the output will be collected across the catcher cavity. Now here, uh, the electron gun is at negative potential. Here, some supply voltage will be applied to this particular two cavity Klystron amplifier. Uh, the electron gun is at negative potential so that it will generate electrons. It will generate electrons, and here the collector or anode, it is at positive potential. The generated electrons are collected by the collector, collected by the anode or collector. That is why it is called collector. It is collecting the electrons which are generated by electron gun. And this is about the construction of two cavity Klystron amplifier. Just now I explained, just to go through the points. One more diagram, just make a glance regarding the operation of two cavity Klystron amplifier. The operation of two cavity Klystron amplifier can be better explained with the help of Applegate diagram. Now here, just now you observe here, this is the position of electron gun. This is the position of electron gun where the electrons are generated focus towards the collector. Focus towards the collector. Now here, what is happening inside? How the amplification is taking place? Let us move to the next slide. Now here, regarding the operation of two cavity Klystron amplifier, just I will read out the first point. The RF signal to be amplified is used for exciting the input puncture cavity, thereby developing a voltage of signal frequency across gap A. Means here, the signal to be amplified is applied at the puncture cavity. And here, the applied signal, you just assume the applied signal will be Vs is equal to some V in let it be V in is equal to some V1 sine omega t, sine omega t. Means here omega associated with frequency. This particular applied signal to be amplified excites oscillations in the puncture cavity and develops the voltage. And the developed voltage is called RF voltage. Now here the electrons are generated by the electron gun, and in between the generated electrons are affected by this particular gap A voltage and travel through the drift space. Now here let us move to the apple gate diagram. Now here in this fashion the electrons are uh, moving, and how they are affected in gap A position. Let us discuss now. Here, this is the RF voltage generated at the position of gap A. At this particular point, B dash, the RF voltage value is 0. The electrons which leaves gap A at this particular instant will not be affected by the gap voltage, and the electrons move with the velocity V is equal to V naught. V is equal to V, and the velocity value is given by root of 2 ev naught by m. Now here, once again, what is the effect of electrons which leaves at points A dash and C dash? Here, at point B dash, there is no effect on velocity of the electron beam, which leaves the gap at point B dash. Now here, let it be this particular electron is unaffected by the gap voltage, and let us assume it is a reference electron. And here the electron which leaves gap A at this particular instant, subjected to, here it is positive maximum of RF cycle. Here it is subjected to positive maximum of RF cycle, increased velocity, moves with increased velocity, that is V greater than V naught. That is at point C dash, the electron which leaves gap A later than the reference electron called late electron, subjected to positive maximum of RF cycle and travels with an increased velocity V greater than V naught. And while coming to the electrons which leaves gap A at this particular instant are subjected to negative maximum of RF cycle, um, and they are decelerated, moves with reduced velocity V less than V naught. Now here once again I will read out point number 4. At point A dash, the electrons which leaves gap A slightly before the reference electrons are called early electrons, subjected to negative maximum of RF cycle and travels with reduced velocity. Okay, here there is no effect on the electron which leaves gap A at this particular instant. And here the electrons which leaves gap A at C dash are accelerated. The electron which leaves gap A at A dash are decelerated. And these three electrons catches up in the drift space and meets at a point, and we call it as bunching process. Now here how the bunching process is going on, let us discuss here. These three electrons meet at this particular point, and here in this fashion, at this particular point, within the drift space, some bunching process means they are meeting at this particular point. They are meeting at this particular point, and here the velocity modulated electrons form bunching by losing energy. The velocity modulated electrons form bunching by losing energy. Now here, why we are calling it as velocity modulation? Here, once if you observe, the electrons which leaves gap A are affected by the gap voltage, means the velocity of the electron beam affected by the gap voltage, and the process is called velocity modulation. And the velocity modulated electrons forms bunching, as electrons in the bunching limit bunch together as they travel down the drift space from gap A to gap B. The pulsating stream of electrons pass through gap B and excite oscillations in gap B. Here, uh, the electrons which forms bunching uh, will move in the drift space and enters into catcher cavity gap, excite oscillations in catcher cavity gap, and how they are forming output voltage. Here, for that, we need to refer point number 7. The density of electrons passing the gap beam varies cylindrically with time. That is, electron beam contains an AC current and it is current modulated. Means here, the drift space converts the velocity modulation into current modulation. A little RF power applied to buncher cavity results in a large beam current at the catcher cavity with a considerable power gain. The performance characteristics, you just make a glance: operational frequency, power output, power gain, theoretical efficiency. And these are the applications of two cavity Klystron amplifier. You just go through them. Uh, Multi-cavity Klystron. To achieve higher gains, multi-cavity Klystrons are preferable. You can observe the real-time diagram of multi-cavity Klystron amplifier. Here one more diagram is there. 4 kilowatt Klystron used for spacecraft communication at the Canberra Deep Space Communication Complex. Few MCQs are there. Dear students, during your regular classwork, you are supposed to answer. You just make a glance. Thank you. We will meet with the next lecture.